Welcome everybody to our Training Tuesday. So today we're going to cover Navel Orangeworm best management practices. And again, we'd really like to thank you all for joining. So today we're really going to cover briefly an IPM program for Navel Orangeworm, and then we're going to dive into the meat of our topic today, which is going to be covered by Emily Symmes. Most of you may be familiar with her in her UC Cooperative Extension role, formerly up in the Northern Valley of Sacramento. Now she's with Suterra. But what I'm going to do first is kind of give us an intro into the pest, Navel Orangeworm, and then jump straight into mating disruption. After that, we have a special guest, Karen Lowell from NRCS, that's going to talk about an incentive program that's available for folks that are trying to adopt IPM practices for Navel Orangeworm. And then we have our very own Ashley Correia that's going to cover some of the cast tools and questions that surround Navel Orangeworm. And again, please hold any of your questions that you have for our Q&A session at the end. But again, feel free to put them in the chat box. I know holding your questions till the end, sometimes you might forget the question specifically. So I encourage everyone again to please use the chat function and we'll filter through those during our Q&A session. So again, let's dive into the basics of Navel Orangeworm, why this is such a big pest in California almond production systems. So Navel Orangeworm, or NOW, is the primary insect pest of almonds in California. So why is that? So worms bore into the nut and feed on the nut meat. So I'm sure all of you have been familiar with this at the end of the season, breaking open a nut and seeing this image here on the right, where you have the frass, you have the worm itself, and it's been feeding on the nut to the point where kernel damage can affect your overall profits. So a good way to identify Navel Orangeworm is looking for these crescent-shaped black marks behind its head. It's clearly easy to identify. Most of you are familiar with it. But if there's any confusion or any hesitation in identification, just look for those crescent-shaped black marks. I think additionally, something that has really been talked about lately is that Navel Orangeworm feeding on nuts themselves creates an issue with aflatoxins. So that's a food safety contamination issue for us in our export market and obviously domestically. So Navel Orangeworm is an issue across the entire Central Valley. I think that's something to highlight where, sure, there's some regionality there, and you can see it oscillates back and forth between North and Central, but the South is consistently where we see the most pressure, at least dating back to 2008. And this is courtesy slide from Mel Machado, so thank you, Mel. But again, this is an area-wide issue. This isn't just one region having major issues with Navel Orangeworm. So again, the idea here is that we need to take a multi-pronged approach to controlling this pest. And what do I mean by that? So minimizing Navel Orangeworm damage. Again, four-pronged approach. We can include other pieces to an IPM program, but I would say these are the main points. So I'm sure all of you guys have heard about the mummy shake videos and everything else like that, but winter sanitation is key. Now, why is that? We get rid or minimize that population for the first flight the next year. They overwinter in these mummies, so targeting that sanitation will reduce that initial population size for the first flight. I think additionally, when we're talking about mummies, we should include the fact that there's inoculum for hole rot as well. So not only is it an issue for Navel Orangeworm, but we should keep in mind that this is also an issue in terms of having inoculum for hole rot the next year. So you're taking care of two things when you're doing winter sanitation. That's something that I think growers and we all could benefit, is understanding the fact that you get two benefits out of doing your winter sanitation, not just Navel Orangeworm control. Secondly is the use of mating disruption. Then we go into monitoring. So these are traps for males or egg traps. Again, this is kind of a good way to monitor and see what the population's doing, when your first flight, second flight, third flight's happening. And then you can use that as a decision-making tool for when to spray or if you need to spray. And lastly, there's the prompt harvest before that third generation. That's where the population really explodes, and it also lines up with nonpareil perfectly. So again, four-pronged approach. I would say the cornerstone of a good IPM program is the use of mating disruption. And that leads us into our larger discussion here by Dr. Emily J. Symmes, again, now with Suterra. So without any further ado, Emily, go ahead and take it away.
Today we're talking about everyone's, favorite beast in the nut crop industry, navel orangeworm. I am going to go in through a little more detail on some general background. So let's just kind of look at the lay of the land and what I call the now situation, or the situation with navel orangeworm in California. There are a number of factors that have kind of contributed to this being not just a sustained perennial pest, but an increasing pest across our nut crop systems. One of these is that we have basically statewide, pardon me, this expanding and really contiguous in a lot of areas of the Central Valley acreage of preferred nut crop hosts. It's important to remember that navel orangeworm doesn't just feed on nut crops. It has a lot of different hosts, both agricultural and more native environment hosts. But you see there throughout the valley in brown almond, in green pistachio, and in blue the walnut acreage. And what we see over the course of the last decade is a 75% increase in bearing acreage. And I kind of look at that picture and think of the Central Valley as a bit of a navel orangeworm smorgasbord, and certainly where you have these interfaces of these two cropping systems, or three cropping systems, navel orangeworm is an increasing issue on a landscape scale. The resource availability, again, is basically, on a time scale, continuous throughout the season. We know that navel orangeworm cycles over winters on the mummy nuts and spends that first and sometimes part of that second generation developing on those mummy nut resources. And then as the season progresses, it attacks the in-season nuts once each different crop splits, and they split over time, both by variety and by crop. So your almonds, then your early split pistachios, then your pistachios, then your walnuts really create this unfortunately great year-round resource for navel orangeworm. We're also seeing that 4 generations per year are common statewide. It used to be that the northern parts of the state, that 4th generation was perhaps only occasional. And really over the last nearly decade now, a 4th generation is the standard all the way up to the Sacramento Valley as well. This picture here just shows a hypothetical degree day biofix model, just showing that if we look back to 2010 and 2011, we had a lag, a slower degree day development for each of these 1st, 2nd, 3rd, and potential 4th generations. And you're seeing that this 4th generation is hitting now, well in time to hit at least our pollinizer varieties, excuse me. And this data was actually taken from the North Valley. We're also hearing evidence of the possible 5th generation being recorded in the southern part of the state. So population potential, this is something that is really important to remember when you're talking about different control tactics, especially mating disruption, that can dramatically reduce this population potential by reducing female fertility. So female NOW have a very high reproductive capacity, anywhere from 80 to 200 eggs or more eggs per female. And what you see here on your left-hand side is a female that's been caught in a female style trap. I'll talk about traps shortly, but this pink here is where she has dumped her clutch of eggs as she was stuck in that lining. And this is one of the standard egg traps where you see white eggs when they're laid, and as they start to mature, they turn kind of orange. We also know that multiple larvae can develop per nut, and they just don't need a high quality resource. This is kind of call it sort of a trash moth or a scavenger. It really does thrive in these icky, lots of webbing, lots of frass, lots of debris environments. What this all means is that we can have very extreme population buildup when our in-season nuts are most vulnerable. So that period of the in-season nuts from hull split through harvest. And that hull split is the critical time because, as we know, navel orangeworm cycles on the mummy nuts before or damage nuts. It really doesn't prefer or have a high capability of getting into sound nuts until they split. So here's just a model of population growth potential, and these numbers are not absolute. This is taking into account what I would consider moderate sanitation to 6 mummies per tree, not the kind of UC industry standard of 2 mummies per tree. This is assuming a carryover potential, or a carryover from the previous season of 2% surviving mummy infest. with only 80 eggs per female. So this is actually a low population estimate. And we're actually including here 50% mortality or migration out or what have you each generation, whether that was induced by a control tactic or some level of natural mortalities. But you can see this generation 1, generation 2, you can see the population starting to develop, but look at that generation 3, and that's what we're often trying to avoid. Those eggs and larvae in our nonpareils really explodes. So with this model, we see a 1900% increase in each generation. And just to put that on scale, when we get out to that generation 4 and potentially looking at pollinizer protection, it absolutely dwarfs even the generation 3 population buildup. So the potential to have millions and millions of moths out in the environment is quite real. Drew already spoke about this. It is a direct pest, which means it gets into the actual harvestable crop itself. That's different than a spider mite that is a very damaging pest, but it feeds on the plant tissue and causes harm that way rather than the actual product that we're trying to sell. And of course, the association with Aspergillus and the ensuing aflatoxin contamination means that the industry has necessarily very low damage tolerance. So these are some numbers that were run based on some information from last year's crop and pricing, but it's estimated that a 2% loss in almonds, for example, can total 105 million, and that is simply from just the quality and yield losses. And then we look at pistachios and walnuts to bring this number. It's estimated that the total cost of just NOW across these 3 systems from quality, yield, and input costs to get to the 2% damage, if that was the kind of industry-wide damage, is roughly 800 million or about 8% of the total crops.
Emily, I think you accidentally was put on mute.
Yes, I did. I apologize. I noticed my rooster was crowing very loudly, so I had to shut the window. Okay, I'm back. Pardon. Working from home. Yeah, he always comes right to the window when I'm doing something like this. So hopefully we've taken care of that. So the total estimated cost to the industry with these kind of assumptions was roughly $800 million or 8% of the total crops value using these particular numbers. So what are the fundamentals of IPM in general, but of Navel Orangeworm IPM? We typically think of, you see these pyramids with different layers, but at the baseline is often monitoring and information, or you'll see it as prevention. And really, and I don't remember who this quote was from, but if we prevent pests, we don't need to control them later. And so we really want to prevent as much of the population as possible. Mating disruption, in my opinion, is something that we should think of as preventative. If we are inducing disruption in mating, we are preventing a significant portion of the population or the eggs and larvae being laid. That can make our cultural, biological, and insecticide practices all the more effective when layered on top of that. So with Navel Orangeworm, we've got kind of these core fundamentals or pillars of the program. Always monitoring and decision support is crucial when developing your program, when evaluating your program, and then when kind of revising and redeveloping your program as you gain knowledge through watching what the population is doing and properly evaluating what your different inputs are doing for you. So with monitoring, we have trap-based monitoring. We monitor crop phenology, we take visual samples, we have degree day models we can use. Decision support, I use that term rather than thresholds. There really are no true treatment thresholds. Again, Navel Orangeworm is a very significant pest, and so the tolerance is very, very low. So we don't actually have true treatment thresholds available in terms of X number per trap means you must spray or do something to avoid X% damage. We don't have that linearity with any of our decision support tools. And we'll talk a little bit more about putting that together. Evaluating your harvest damage. doing it really from a ground sample in the field is the most ideal. The grade sheets can miss some damage and aren't always as precise as we need in order to determine what the actual cause of the damage was. And I include mass trapping here because it doesn't really fit anywhere and it kind of uses traps. So it's actually a more of a control practice than a monitoring practice. And we do know that there are both almond and pistachio folks that are using mass trapping successfully in their orchards as a layer of their program. We have mating disruption. We'll talk quite a bit about mating disruption today and the different platforms. Generally, we have what are called aerosols, we have dispensers, and sprayable microencapsulated formulation. Cultural practices, of course, are critical. Among those, sanitation and timely harvest, minimizing damage from other sources, and what I like to call year-round mummy management. And I'll talk in detail about what I mean about that. There are biological control agents in the environment. There are a couple of parasitoid wasps that lay their eggs in the egg or egg larval stage of navel orangeworm. They have typically not been heavily relied upon or considered to have much impact in the system. I personally, based on just observations, no actual hard kind of experimental data, but just observations of having cracked out almonds at the end of the season for nearly, a decade and dating back actually to my teen years. I'm seeing actually significant levels of parasitism in those crackouts where it was very, very few and far between. And I think that is reflective potentially of the shift from some of the harder chemistries to some of what we consider the softer or more specific chemistries, and perhaps an increase in mating disruption, also allowing these biological control agents to survive and flourish a little bit more. I think that it's worth looking at some research on the prevalence of these in the system these days. We typically don't rely on like purchase or release of biological control agents for navel orangeworm in the system to any degree, but knowing what's out there and conserving the populations of the natural enemies as much as possible is really important. And of course, we have insecticide options primarily in the system right now. The top three listed there are the ones that are most relied upon for navel orangeworm management. So let's go into a little bit about monitoring and decision support. I think there's some maybe misconceptions about what the different monitoring tools, especially the trap-based monitoring tools, can tell you. So typically, what do we monitor and when? It's really important to go out and evaluate your mummy load, your overall mummy load over the winter, either before sanitation to guide where you need to put those sanitation efforts in the most, and after to get an idea of how good your sanitation was and potentially what kind of pressure you might have given the fact that maybe your sanitation wasn't as ideal as it could have been for whatever reason. We like to also go out and do a subsample of those mummies to determine mummy infest. This can give you an idea of your baseline population going into the season. Again, allows you to start sort of pre-planning for what types of inputs you think that orchard or block should need. You pair that obviously with the history of damage in a particular block as well. We monitor crop phenology, so we can use the full bloom date to predict when hull split will happen. That hull split's an important timing for navel orangeworm access to the in-season nuts and a lot of our chemical inputs. And then obviously we go out and ground truth that to understand when hull split and the different stages are actually happening. Monitoring the pest activity itself, both through trap-based tools. We do this spring through at least harvest. We like to keep an eye on those traps post-harvest. A lot of times we see a lot of population activity all the way. Usually it's been until like the first week of November with the moths flying around. And that can give you an idea of what type of population might be out there impacting the new season mummy nuts. Visual assessments approaching hull split are maybe less common now that we have a lot of the trap-based tools, but still very valuable, looking for actual eggs being laid on the nuts near the sutures around early hull split timing. And then again, I mentioned harvest damage, getting out and taking your samples from the field itself and cracking out to determine what all of your kind of damage looks like, but especially which could be attributed to navel orangeworm. So these are generally the types of traps that are being used for navel orangeworm. We have the egg trap. This is filled with either ground almond meal or ground up old pistachio coals. Excuse me. This is called the Delta style trap. This has a pheromone lure in it. This is called a wing style trap. This, I believe, is experimental. This is not what the commercial lure looks like, but this is what's called a PPO, or phenylpropionate lure. And then this is what is collectively kind of referred to as the Peterson trap, or we'll call it a bait bag trap. And this is just filled again with ground up old pistachio meal. So what do each of these trap-based monitoring tools do, and what are some of the features to consider about them? So the egg trap, the target, what we're trying to find out is female oviposition activity. The pheromone trap attracts and captures specifically adult males. Males are the ones attracted to that pheromone. The bait bag trap attracts adult females. These are mostly gravid, data suggests, or that means already mated. And then the PPO plus pheromone. This has been shown to capture both adult males and females. And this is the one that research suggests, Chuck Burks has done a lot of the research on this, that this is the appropriate or best option right now for monitoring within a mating disruption system. And we'll revisit this slide when we get into mating disruption. It's important to understand what the trapping radius is in terms of like the density of traps you might need to put out, or what you can expect in terms of detection sensitivity. So the egg and the bait bag traps typically have a small trapping radius, which means they don't attract from a really long distance. The pheromone trap has a large trapping radius, and the PPO plus pheromone trap is considered intermediate. This kind of leads into what we call detection sensitivity, which is, what's your likelihood if there are females laying eggs in the environment, or females in the environment, or males, what's your likelihood based on where your trap is placed of actually detecting those? Again, because of that trapping radius, the egg traps and bait bags typically have a lower sensitivity, catch fewer moths. The pheromone trap has a much higher detection sensitivity, tends to catch a lot more moths if you're not in mating disruption. And the PPO plus pheromone, again, typically doesn't catch a really high number, but it is something that you can use to track at least the flights within mating disruption. When we talk about trap design, we're really talking about the difference between the Delta trap and those wing style traps. The egg traps, there's a couple of different designs from different manufacturers, but they're generally the same, so it's not super critical. The pheromone trap, because it is quite sensitive or quite attractive, seems to be less critical. And so we often use the Delta traps just because they're much easier to service. With the bait bag and when we do the PPO plus pheromone, the data really does suggest that the wing traps allow for increased trap capture. There's surface area and kind of more airflow there. The importance of trap placement and how many are going to be more critical on those with like the smaller trapping radius and reduced detection sensitivity. So where you place an egg trap or a bait bag trap in the orchard may have a much more significant impact on what you're catching than a pheromone trap, for example. And you typically need more egg traps and the bait bag style traps and the PPO plus pheromone traps per acre or per block than you need the pheromone traps. So what do the traps actually tell you? All of them allow you to track either the flights or phenology to some degree. They can all give you an estimate of relative population density in terms of block to block or year to year. It's important to understand that only the egg trap is the one that has a validated model for which we establish the biofix date and then calculate ensuing degree days to predict the next generation timing. That has not been validated for these other styles of traps yet, at least not academically. The egg trap can be used to inform treatment timing, and the others possibly so, but not necessarily related to a degree day model. And again, I mentioned before these treatment thresholds or damage potential. It's unclear again, there are no like linear correlated treatment thresholds. When it comes to trapping, and that decision support and all of that monitoring, there really is no single method to answer the questions. Do I need to treat to avoid a certain percent damage? If so, how many? What's the most ideal timing? Based on what my traps are saying, are there additional more stringent inputs warranted? But you guys, with the experience that you have year to year to year, you can start developing those understandings again with that relative population density. And so really, when we talk about navel orangeworm kind of monitoring and decision support, I think it's, it's a lot of science. It's actually quite a bit of art, and then a big sprinkling dose of both experience and then those operational realities of, if this is the most ideal absolute timing for a specific treatment, but what's the operational reality of getting to every block at that most ideal time. Cultural practices are actually a number of cultural practices that are critical. Sanitation, we know, I won't hammer that. The industry knows how important that is. A note on that, though, is when you are basically flailing or trying to destroy the mummies once they're on the ground. Watch that mower height and speed, and make sure that you're actually destroying those to the degree that you want to. We know that maintaining ground cover in winter where possible can help with mortality. That assumes significant rainfall. I will say that up here in the Sacramento Valley, mummies on the floor this season are absolutely fine and would make great homes for navel orangeworm. So we really can't rely on that too heavily. Minimizing earlier season damage from other sources is important so that navel orangeworm can't get into those nuts prior to hull split. Horticultural and disease management practices that minimize sticktites and mummies. I'm going to go through a couple of slides of that. And then also just remember that there are some environmental factors we can and can't control, but some that we can, including like irrigation and nitrogen management, that can impact crop size and therefore shell seal. When we typically think of a smaller crop set, those individual nuts are often larger, can have a looser seal, relatively speaking, and then there are overall fewer NOW, what I consider homes per acre in terms of the number of nuts per acre. When you have a bigger crop, the nuts often are not as big, so they're smaller. They often can have a tighter seal, and this also, though, means more NOW homes per acre. And of course, timely harvest as much as we can control. You obviously don't want to try to shake too early, but we do try to get the nonpareils out before the bulk of that third generation is able to lay eggs on them. So as Drew mentioned, sanitation, it's not just for navel orangeworm. So it can reduce pathogen inoculum from a number of different diseases in the system. And then this was actually a great article that Wes Asai wrote, and I don't remember where I saw it last year, but consider the fact that commingling of mummy nuts with a current season's harvest can add to the reject percent. And that was his picture there in the corner of mummy nuts that ended up in the current season harvest on the left side of that bottom photo. So let's think about the cultural practices that I call year-round mummy management. And what we're really trying to do is minimize the sticktites that are going to stick in the orchard, not shake out as easily, and then contribute to that mummy load that then we have to go in and add additional inputs or resources to have additional shakes later, assuming we get good fog or enough of that kind of weather to help assist the loosening at the peduncle, and certainly, hand pulling to follow as needed. So remember that irrigation and nutrients can have significant impacts on crop removal in terms of overall tree vigor, the onset duration of hull split, the synchrony and tightness or delayed of ripening, disease incidence, and then boron toxicity can also result in gummosis and sticktites. Diseases, anthracnose and hull rot also can cause gummosis at the peduncle and cause issues with shaking. Other insects, especially the plant bugs and stink bugs, hull gummosis can be caused through feeding by these insects at certain times of the year. And this one's pretty interesting to me because it's a bad feedback loop that you can get into. So if you've got uneven ripening or sticktites for any reason, these can become harder to remove, which means you might shake a little bit harder and then have some shaker damage to the tree. Shaker damaged trees are more prone to stress and disease. That then can lead to more stick tights in the next year. Damaged trees can use less water. These can be over irrigated, which means more disease and potentially more stick tights. And then you kind of have that cycle again where you have more stick tights being more difficult to remove and increasing your shaker damage risk. So think about this kind of year-round mummy management in terms of all the other benefits of managing all of this properly, but also when it contributes to your navel orangeworm overwintering resources. So a little bit about insecticides. Primarily, we're relying on just a few modes of action. Again, the diamides, the methoxyfenozide insect growth regulators, and pyrethroids still tend to be the most common in the use. There are little to no new modes of action materials in development. It's important to remember that things like the diamides and methoxyfenozide require very precise timing, really targeting that early first instar when it is susceptible and when it's in a place before it gets into the nut where the chemistry can no longer contact it, and excellent coverage. So there are obvious resistance mitigation concerns when we're relying on just a few modes of action. And of course, there are non-target issues, both for beneficials and pollinators, where we're not spraying for NOW when there are pollinators in the environment. But certainly we always want to keep that in mind. And then, of course, the environmental impact considerations. So it's important to note, though, insecticides are obviously very critical tools in the toolkit, but we've got to use them properly so we can preserve their lifespan for continued efficacy. Just a few quick snapshots of resources for non-target impacts from UC-IPM. They've got some great information available, both for the natural enemies in the environment and the commonly used pesticides, and then a great honeybee precaution pesticide rating database. So just another couple of quick notes, just kind of substantiating the insecticide use. As we know, chlorpyrifos is gone. And so you see that use in California almonds is pretty much nil. Pyrethroids still continue to be used, on a fair number of acres, but we see that diamide and methoxyfenozide use in California almonds going up over the last roughly decade or so. But we also see this is the active ingredient in mating disruption, and that's what we'll talk about for the rest of my time, for use for navel orangeworm in California almonds. So we obviously see that big spike in 2019, and we don't have 2020's data, but we're seeing increased adoption of mating disruption across both almonds and pistachios. It's important to note also, mating disruptant use is often heavily underreported in the pesticide use report data. So these numbers might not reflect all of the use that's happening. And that's an important note to remember, that no matter what type of mating disruption platform you're using, you're supposed to report those on your pesticide use reports. Even though it is pheromone, it is still considered a pesticide. So mating disruption, let's just kind of go through what is happening and how we actually disrupt. So what we're doing is we're exploiting what's happening naturally. Insect chemical ecology, meaning the pheromone in this case that the female creates and emits, and the way that the males respond to it in order to find her and have successful mating. These are innate behaviors. These are reliable behaviors that we can exploit. They're highly specific to the individual species, the pheromone molecules, and they're absolutely necessary for their evolutionary success. Navel orangeworm must mate to lay fertile eggs. So what happens naturally when you don't have disruption in the environment? Females produce and release very, very small quantities or concentrations of her pheromone. The naturally occurring pheromone molecules are very fragile, and these pheromone plumes don't persist for long at all in the environment. And that's by natural design. Otherwise, they would sort of be causing their own mating confusion, because if they persisted for any length of time in the environment, the males would catch the plume and potentially go upwind, and she wouldn't be there anymore. So what's happening naturally in the environment is the female, typically sits on part of the plant and emits her pheromone. The wind creates a pheromone plume. What's really important for the male to be able to find her is actually these little pockets of air where there is no pheromone concentration. So the male will find that sort of pheromone plume and zigzag kind of along these concentration gradients until he falls out of the plume, so to speak, and then he'll cast until he finds it again and keep going until he ultimately finds that source of that plume that he's looking for. So how do we disrupt mating in the environment? We exploit these innate behaviors and the ecology. The chemical structure of the synthetic pheromone itself in the mating disruptants are identical to the naturally produced aldehyde component molecule of the pheromone. And what we do as mating disruptors is we get a lot more pheromone into the environment and create longer lasting sort of distribution and emission of those kind of pheromone clouds that mask her natural plume in the environment. And we do this through very, very highly technical formulations, through different release technologies, through different platforms. Point sources control the emission rates, the pheromone concentrations, and the distribution in the environment. So again, there's a couple of ways that disruption actually works from kind of a mechanistic level. One way is called competitive attraction, in which case the male is actually diverted from the female and very directly casts upwind to one of the dispensers or kind of aerosols or what have you that are out in the environment. That's the case for an insect like codling moth. For navel orangeworm, it's one of these non-competitive mechanisms, it appears, in which case there's either a camouflage effect where she's still out there calling, but there's so much pheromone in the environment he can't pick up what's real and what's not. A mechanism called sensory imbalance where he just doesn't know how to properly respond. His nervous system doesn't know how to interpret the chemistry in the environment. And then there's the what I call the nose blind effect, right? This kind of, there's just so much of the quote smell in the environment, he adapts or habituates to it and just no longer really can sense it or cares about it. So here's just a couple of kind of graphics that you can think of potentially aerosols at 1 per acre and that sort of cloud of pheromone. And then we'll talk a little bit about the sprayable microencapsulated formulation. This we think of as basically billions of tiny little point sources that you spray on and spread throughout the environment. And so in a natural setting here in the middle, again, you have these sort of pockets of no pheromone air that allows the male to properly orient. When you basically blanket this whole environment, he ends up not being able to find that female. So important to remember, mating disruption is basically an insect behavior modifier. It doesn't kill anything. It's not an insecticide, but rather it prevents the next generation eggs and larvae and pupae and adults from ever existing to begin with. So remember that. So we're preventing significant portions of the population. If you come back in with an insecticide that has roughly 50% efficacy, you're now having to kill much fewer individuals. So it makes that investment all the more important or effective. So we prevent mating, but what we also do is we can delay mating. We know that the bulk of navel orangeworm kind of fertility happens in the first few nights of the female's life. And so even if she ultimately ends up getting mated with a mating disruption, if it's delayed beyond the first few nights, her fertility level and success goes way down. So we reduce the fertility in the population, and ultimately that leads to reduced damage or less worms in our nuts, and that's what we're all about. What are some general benefits of mating disruption and the overall IPM program? We don't have to go through every single one of these, but these are kind of my I don't know, Jeopardy grid, so to speak, of some of the most important. The high specificity, that's really critical when we're talking about preserving beneficials, known on target impacts. We're not blowing up spider mites or anything by applying these. We know that it reduces damage. There have been a lot of research that shows that. Return on investment, in many cases, it absolutely pays for itself and then some. It allows for flexibility in the overall integrated pest management program. And what that means is if you've potentially if you've got, a season-long mating disruptant up, you can spend your time kind of focusing on other critical components of your pest management and operational program. There are season-long options, and many of these, if they remain in the orchard, still have juice in them post-harvest when those big fourth flights are happening. There are a number of organic options. And again, we know that we have some conventional pesticide limitations, whether that is potential for resistance development, potential for more regulation. And so we're needing to really prolong the lifespan of what we have and start embracing and getting comfortable with some of these other sort of modes of action or technologies that can help reduce the pest population. And again, we call them these superior safety profiles. So, MRL exempt, most of them have either 0 or the sprayable has a 4-hour reentry interval, and most all of them have a 0 pre-harvest interval. So you're able to get that protection that entire time up to harvest. So, what are some kind of things to think about for successfully incorporating mating disruption? So I've decided that I feel like it's a fit for my operation. It can help with my NOW program. First is choosing what we call platform. So I'll show some photos of that, but basically which style of mating disruptant you'd like to use, and a use pattern. That's a little more critical if you choose the sprayable formulation. And ask a lot of questions from the technical reps of these companies. They really know their products very, very, very well. So ask a lot of questions, understand how they work, what they do, if there are additional features, understand what those are and what benefits those bring. We'll also talk about monitoring within disrupted orchards and look at a little bit of an ROI type of interpretation for your overall program. So these are the 3 primary mating disruption options for Navel Orangeworm in the Almond system. We have aerosols, we have the sprayable microencapsulated formulation, and there are dispensers available. With the aerosols, I believe all of them go out at a rate of an average of 1 per acre. These all release pheromone nightly at some pre-programmed interval, and they're propelled. That basically the pheromone formulation puffs out or is propelled out of these devices, and these all last season long. The sprayable microencapsulated formulation goes on at a rate of 3 fluid ounces per acre. It releases again. These are like tiny, tiny little dispensers, essentially microscopic dispensers. And so they're constantly releasing the pheromone that's inside of that microcap for up to 30 days in the environment. And these are applied with any type of traditional spray equipment. They can go by ground or air. And in certain cases, folks are doing ultra low volume applications of these. If you use the sprayable as a standalone and it's not in a tank mix, because it's not an insecticide, we're just getting the pheromone in the environment and the microcaps to release. You don't need to have thorough coverage, which means if that's the only thing in your tank, that and water, you can go at faster speeds, every other row potentially, and much lower volumes, and it allows you to get across the block pretty efficiently. The dispensers, the label rate for these is 15 to 28 per acre. Again, being a dispenser, it releases 24/7. The reason the aerosols release nightly is that's when the mating actually happens. Aerosols are available through Suterra, Pacific Biocontrol, and Symmes. Both Suterra and Symmes have an organic option for the aerosol. The flowable is manufactured by Suterra. This is not currently an organically approved formulation. And then the dispensers are made by Trace, and I apologize, that also is an organic option. So that should be stated over with the dispensers also. Let's go a little bit into kind of overall NOW phenology and how not just mating disruption, but your whole program kind of overlays with this phenology, and where potentially you are targeting different parts of this life cycle with the different management tactics, potentially with the mating disruptants and what the goals are. So we know that the larvae overwinter in those mummy nuts, and then they give rise to that first flight. Typically, we see it coming out mid to late March in most recent years. This is a long first flight typically because we don't have all the heat units, and so it's a bit of a slower development. And we tend to see this flight last through May. These moths give rise to the first generation eggs and larvae shown here. One of the reasons that May sprays can be particularly challenging, again, is because this is kind of a longer window of getting like an insecticide residual coverage period to cover this particular longer kind of staggered coming out generation. We typically see the second flight often now coming late June. Giving rise to the second generation, and here's where you've got your hull split, and these eggs and larvae are getting now into the new crop. And then this bulk of this third flight and this third generation is what we're trying to avoid with early harvest. And then we have this fourth flight that's happening out there and getting into pollinizers and pistachios and walnuts. This is just a graphic of what your pheromone trap capture might look like. You've got that longer first flight. Then a second flight often kind of going on when hull split starts. And then these third and fourth flights, because we have those heat units building up, often you see some overlap with those because they're now developing on the new crop nuts. So it takes fewer degree days for them to develop. And it's also the hottest time of the year. So we're getting a lot of those degree days that's pushing development. And this just kind of reiterates that what that graph showed is that the population size increases throughout the season because of increasing temperature, resource availability on the new crop nuts, and then the quality of the new crop nuts. Kind of talked a little bit about this. So just kind of resource utilization, mummy nuts here for that overwintering generation, first generation mummy nuts, second generation will either go back to mummy nuts before split and then onto the in-season nuts once they split. Third generation is going to be on almonds and pistachio and walnuts. And then that fourth in our pollinizers and remaining pistachios and walnuts in the environment. So where do each of our control tactics or management tactics come in? Obviously, sanitation there in purple is targeting those overwintering larvae. Not only that, but we're reducing homes and resources for the bulk of this first generation and some of this second generation. We're just reducing resources. Fewer mummies mean fewer places to lay eggs and successfully develop larvae into adults. What's your aerosol doing? So typically with your aerosol or dispenser mating disruptants that last season long, those typically go out late March, early April, and your target here season long are the adults. Again, we're not killing any of the eggs or larvae. What we're doing is blocking mating of these adults and dramatically reducing the numbers of these eggs and larvae in each subsequent generation. With the sprayable mating disruption option, the typical use patterns that we've seen are tank mixing around those kind of hull split treatments during the summer to protect that in-season crop. But certainly you can apply a sprayable mating disruptant to target the bulk of any of these flights. With the sprayable, most folks like to get the free ride of a tank mix. And so often, again, we'll come in with this first hull split spray. I think sometimes we're missing the very first part of that second flight when we do that. But certainly if you spray with your hull split, you get up to 30 days out of it, you're getting some good coverage here. And then again, that overlapping kind of third flight. Folks haven't done, to my knowledge, a lot of what we call the May sprays or mummy sprays with the sprayable mating disruption, but certainly I think that that's something worth potentially considering. They're quite affordable in terms of sprays. They're roughly $30 an acre, so they're right in line with, kind of in the middle of a cheap insecticide to one of the more selective, more costly insecticides. But again, because that May spray window with an insecticide and the not terribly long residual period, you may get kind of more legs out of a spray at this timing with a pheromone that then ultimately reduces this population and all of those after. But use patterns with the sprayable are flexible, and that's kind of one of the benefits. Again, your insecticides, what's your goal? Unless we're using a kind of a pyrethroid with some adulticide knockdown activity, the Altacors and the Intrepids, the diamides and methoxyphenozides are largely going to be, applied to kill those first instar larvae. Residuals for those can vary, and those are susceptible to environmental conditions also. And then, of course, that timely harvest where we're trying to avoid any of these third and fourth generation eggs. So how do we monitor within disrupted orchards? I promised that I would sort of bring this slide back up. So the egg traps and the bait bag traps should not be impacted to any significant degree by having the pheromone in the environment, because the lure or attractant in those is not a pheromone. So the traps aren't competing. They may be impacted in the fact that your population is overall suppressed, so they may be lower in that sense. But what really is the most important thing to see here is that the pheromone traps typically will be dramatically suppressed when you have mating disruption in the environment. You should still run your pheromone traps. This is kind of an in-season check to make sure nothing's going wrong with your mating disruption. And so you want to continue, especially where you have the season long, to see that significant trap suppression in those pheromone traps. But it will become necessary to use these other types of traps. And again, specific data suggests that the PPO plus pheromone lure in a wing trap is the best option that we have available right now for trap-based monitoring within disrupted orchards. Let's talk a little bit about return on investment, interpreting the return on investment, and a little bit about teasing apart the efficacy of individual inputs. So this premium schedule is courtesy of Blue Diamond. Mel Machado is always very gracious with everyone and sharing their data and information. This was from 2020. So this is not necessarily this year's schedule, but a very recent schedule. And what you're looking at are just some assumptions here. So average yield of 2,500 pounds per acre. Your USDA grade sheet is reporting this level of percent damage in your crackout. We always double that in the almond system because the NOW heavily infested nuts are often lighter and they don't make it all the way to that grading process through the harvest activities and the huller and the processor. And so it's important to realize what was left, basically what yield was left behind in the field when running your calculations. So we consider this column here to be the total NOW percent that's running into these calculations. Base value of $1.75 a pound, and then this is the premium schedule. So you see that if you're going from 0 to 1% damage, you're kind of in the red by over $120. And that number alone covers mating disruption, at least the products themselves in most cases, unless you've got additional add-ons to the program. Pays for the disruption, the season-long approaches, and then some, and certainly could afford you multiple of the sprayables. So this is kind of what I like to think about, and of course this is sort of a plug and play, and you would look at your own program and your own results at the end of the year. But let's just say that for scenario A, you didn't sanitize at all. Without sanitation, you got pretty lucky at 3%. You did three insecticide applications, 1 IGR, 1 diamide, 1 pyrethroid, and didn't have mating disruption in the environment. And these are the numbers that are going into these calculations here at the bottom. And so you can see that your input costs for your management program here were $108 per acre. So that netted you roughly $4,100 per acre at 3%. Let's say that you did kind of a low input sanitation, so you invested $150 per acre to sanitize, and then did 2 insecticide applications and 2 of the sprayable mating disruption applications. So you increased your costs by $200, but even just reducing to 2% damage here, actually, you're in the black by $46, even with that added input cost. Let's say that you went season-long mating disruption, kept your 2 insecticide sprays, and upped the ante on your sanitation. You're looking at a much bigger cost per acre in terms of your input costs, but you got yourself to 1%. And with the added yield plus the premium schedule, now you're up versus scenario A, and so on. And so you can basically run these numbers for yourself. What's really important to understand though is this is a full program, right? Which of these, teasing apart which of these was the reason you got to 1%, probably a combination of all of the above. And so when you're looking at specific input costs, for example, did that particular spray make the difference, or did that particular addition of mating disruption make the difference? It's actually quite hard for a pest like Navel Orangeworm to really fully tease the individual inputs. So really think about your kind of ROI from a full holistic kind of program approach. Again, kind of just touched on that first arrow or bullet there. That's looking at a single year snapshot also. So think about the fact that really with any input, but specifically with mating disruption, whose primary goal is to just drive those populations down and down and down over time. Remember that ROI on continued mating disruption investment is essentially going to amortize itself year after year as you start to get those populations down, and potentially think about pulling back or reducing potentially some of your other inputs where it's appropriate for your landscape scale and some of the external pressures. You've got your internal kind of resident population very low, then you can start looking potentially at your other spray program. There's also, of course, kind of these intangibles or non-dollars and cents kind of return on investment considerations. And these are things like sustainability goals, whether that's your personal ideology, your operational kind of goals in your practice. Certainly commodity and marketing boards like the Almond board and their sustainability goals. Again, we have some forced sustainability goals through continued regulation. Marketing and PR, there's lots of different sustainability certifications and branding now, and using techniques like technologies like mating disruption are often recognized within those types of things. And then I think this is a great segue, and I didn't just add this here, we actually always put it in the slides, but there are potential financial incentives like through NRCS, which you're going to hear about also today from Karen. And with that, I'll turn it back over. I'll stop sharing my screen, and I think I got us close to back on time.
That was fantastic, Emily. Thank you so much. So that was a perfect segue to our next piece with Karen Lowell. Karen, are you on the line?
Queue up. Couldn't have asked for better. I will move through this fairly quickly because really what I would encourage people to do is to meet with their local NRCS office to get detailed information that's pertinent to their systems. So I want to, and I apologize, I think I forgot to turn on my video so folks who want to know who they're looking at can see me. So there you go. We had NRCS, the USDA Natural Resources Conservation Service, has a whole process by which we will work with producers to identify any resource management concerns that they have associated with their operations. We cover everything: soil, water, animals, plants, air, the economic considerations like the ROI that Emily just touched on is important, and we recognize it's critical for producers. Energy, that's our shtick in the intersection with producers in the farming community. So we have this 9-step process that we work through, and I always try to touch on this. I know what you're keen to hear about is how we might be able to offer some financial support to adopting a comprehensive program like Emily just described. But I just always want to remind people that the way that goes out the door for us is to go through this conservation planning process. So when you go to NRCS to discuss opportunities to support financial assistance for this or anything else you're doing in your operations, it's really important to understand that's what the planner has to do. They can't just do some small piece. They need to have this conversation with you. It quite often lands on exactly what you're there to discuss, but please understand that so that you can get the most out of the services that we have to offer. There might be irrigation water management things that can be updated, or you know, cover cropping or pollinator support plantings. Emily mentioned the biological controls and beneficial insects, if you want to think about that. NRCS could also help with some of those things. But today what we were talking about is this program that would apply mating disruption for control of navel orangeworm. So that's what I'm going to focus on right now. I just looked a year ago, I gave a talk that described some updates in our conservation practice standard that addresses supporting producers as they think about their pest management activities. And at that time, I said we were moving towards getting documentation in place so that we could help specifically with navel orangeworm. Well, we're ready for that now. I will caution you that not all of the offices are as prepared. So at the end of my presentation, I'll make sure you have my contact information. So should you have challenges, I'm happy to take your call and help you get support wherever it is that you might be speaking to NRCS. I cover a chunk of the Central Valley where a lot of our almonds are grown anyway, so that's fine. So I'm just going to run through quickly. If you would like to work with NRCS to get some financial assistance to offset the costs of adopting what we would consider a comprehensive IPM-based program, including mating disruption for the target pest of navel orangeworm, I'm going to run through what would that look like? What would you be, quote unquote, required to do to be eligible for that payment? Of course, there are eligibility considerations just to ensure that you're eligible for USDA funds. And I want to make it really, really clear that we are not creating our own guidelines. We're partnered with UCIPM. Everything that I'm going to show you has been vetted and extensively discussed with David Howland and Glenn in the UCIPM system. So NRCS does not give pesticide recommendations. We do not tell you how to manage your pests. What we're incentivizing is getting you to exactly the kind of program that Emily just described to you. So we're incentivizing you adopting an IPM program. So it's not a piece of it, it's the whole program that with the consensus of our UCIPM specialists, we've developed what would be considered a credible IPM program targeting navel orangeworm, including mating disruption. So to work with us, what that would include would be to share with us a list of the pesticides that you're using in your orchard to control navel orangeworm. And the reason for that is because we're an agency that is tasked with evaluating hazards. And so that's what we're doing. We're just going to run your pesticides through our hazard assessment tool and just let you know how that comes out when we enter your pesticides and your soils. So it does not preclude you participating, and we're not going to tell you you can't use those chemicals. We just do that hazard assessment because it's part of our job. They're public funds. It's part of what we're directed to do. But again, we're not going to tell you you can't use any of those pesticides. It's just part of the hazard assessment that's part of our process. And then we're going to direct you to the resources in the UCIPM website for the target pest. And then we'll ask you to document specific management activities that would support control of navel orangeworm in your orchard. And let me just spell that out a little bit more detail. The key things are exactly what Emily hit on, the orchard sanitation, and the piece that I think is important to understand is because we're incentivizing it, we won't just ask what was your observed mummy nut count. We'll ask if you didn't reach what's described as the threshold in the UC system, that you document that you invested some financial effort in getting those numbers down. So the $200 per acre is from a cost study that is roughly the cost of sending a polling crew through. Note, we are not requiring that you reach the threshold because some trees, some varieties, you're just not going to reach it in any economically feasible scenario. And so we're not requiring you meet it. We're just requiring if you didn't hit it, that you invest the effort of sending a polling crew through to try to get those numbers down. We would ask for the types of traps and the date they were placed. We would ask for your monitoring results. Now, if you have a PCA that's doing that, you can just provide an invoice that shows, yeah, they did this service for me. We're not going to evaluate it and tell you whether it's right or wrong. We're just providing documentation that public funds went out the door for something that we have approved and run through with our partners at UC. If pesticides are used, which at this time my understanding is that mating disruption is not at a point where they're not, I guess the long goal, the big picture goal would be at some point to reduce the pressure so that we might start to be able to reduce sprays, but that's at this time not what we understand to be the program. So pesticides can be used. We're not telling you you can't. We just ask again that you tell us what you applied. And you can just submit your pesticide use report if that's easier for you. And then also information about what mating disruption product you used, the name, the rate, et cetera, on the acreage for which you're contracted with us. The harvest date, because that is part of a program that would include, as Emily spelled out, sort of prevention, avoidance, using monitoring, and then suppression as necessary, or PAMS, sort of the core of IPM. But you won't, that's not used to deny payment. It's just something we're asking you to document because it's part of a system of helping you track the things that would be relevant as you manage this pest. And then we would like to see what you find when you did your post-harvest assessment of damage, you know, what pests did you observe and what number and so on. And then anything that you need to apply for control, just information if there's any sensitive areas, waterways, or if you have planted some beneficial insect habitat, how did you avoid a spray that would drift into that area, so that kind of thing. But that's basically what we would ask you to provide at the end of having implemented the practice. It's all right if you're already, I think most growers are probably already doing orchard sanitation at some level. So we're asking that the whole package be adopted. So we can't work with you for payment. We can work with you for technical assistance, but for payment, we would require this whole package. So that would be if somebody's already doing orchard sanitation but hasn't really found it feasible to do the mating disruption for cost reasons, we're a good fit for that, right? You can come talk to us. We can see if we can help offset the costs of adding that to your management program. And that's basically what we would ask for in this implementation. Again, we'll ask for your pesticide use, not to say that it's not allowable if you're working with us, just because that's part of our job. I think that's often a trigger point for growers. They don't particularly want us telling you how to manage your pests. We're not going to do that. We're just going to say we need to know it because it's part of our job to document that. So that is, in a nutshell, what we are set up to do now with the changes in what we call our pest management conservation system. It used to be called Integrated Pest Management. It's the same number, 595, that you may have heard in the past. And again, I welcome your calls, your emails. Email is usually the best way to get me. Feel free to call me and I will try to catch it. That's my cell number there. And the the best thing to do if you think this might be of value to you is get to your local NRCS office and tell them that you're interested in doing this with us, and then start the process of making sure you're in the USDA Farm Services Agency's records and that you've moved through the application process, because as I said, it's not, for us, it won't just be one thing. It will be, I guess I can leave that out. It will be all of those soil, water, air, plants, animals. They'll talk with you about that. You don't have to tackle it all, but that just is all part of our process. So that's what I had, Drew, and I'm happy to take questions by email or any other way if folks have them.
Great, thank you so much, Karen. So I really hope you guys could take away from this, between Emily's discussion and then what Karen just covered, is that managing navel orangeworm really is an integrated program. One piece alone isn't going to get you where you want with the numbers that you're looking for. And really, you do get a return on investment, like Emily showed, once you integrate an entire program. So again, Emily has showed through a lot of her slide, a lot of her information, a multi-pronged approach. Sometimes there's issues in terms of just being able to afford an entire program, and that's where Karen comes in and NRCS comes in to be able to offer some incentives for folks to adopt some of these practices if there was a hurdle there. So next up we have Ashley Correia. She's our field outreach and education specialist, and she's going to present a little bit on some of our information in CASP and some other tools, and then we'll lead into our Q&A. So I know a lot of you guys have posted questions in the chat, so we'll get to that shortly. Give me 1 second here. Okay, Ashley.
All right, thanks, Drew. I'm going to go ahead and go to the next slide. Okay, so for those who don't know, this is our California Almond Sustainability Program. It's an online platform that we encourage all of our growers to participate in. It's really easy to set up an account. So you can see this is the homepage if you go to sustainablealmondgrowing.org. And once you're there, you can either one, create the account, or two, if you've already created an account, you can just sign in using the user login button. And most importantly, if you forgot your password or if you have forgotten your username, there's lovely little icons there that say I forgot, and that will allow you to receive those links in the email. Drew, if you click one more time, there might be something that will circle it for you. Yeah, one more time. Okay, so see, as there are little spots there, it says I forgot. This will be a great opportunity. I understand sometimes keeping passwords are very difficult. We have a lot of them, but the software is really great about if you've lost it, they'll help you figure it out. And to remind you, this is powered by Sure Harvest, which is a third-party organization that keeps track of all of the information so that the Almond Board does not house this information. It is only given to Almond Board in aggregated data. So that's just really important to know. So we're going to go into the CASP questions that we're focusing on now. So ultimately, the platform, it has 9 different modules to complete one full assessment for the crop year. And the ones focusing on NOW are found in the Integrated Pest Management module. So as you can see here are the highlighted questions for NOW, starting with question 68 and going down to 73. And it's in the category of insect and mite pest prevention, navel orangeworm, or NOW. As you're going through this, these are self-assessment questions, and these are questions just asking you, hey, are you doing these practices in your operation? And if so, give yourself credit. So for example, on question number 69, it says, by March 1st, was mummy nuts on the ground were destroyed by mowing or disking? So were they? Yes or no? So if you were doing this type of practice on your operation, you would click yes, and then it would log your information in the assessment. And then it kind of goes down and talks about, are you using mating disruption? So kind of going into what Emily had discussed earlier today, are you doing these type of practices? You know, are you looking at your irrigation or doing, you know, deficit irrigation? Are you making sure your harvest is timely? So all these questions do impact navel orangeworm management. So it's really important. If you aren't doing these practices and you want more help or questions on it, you can go ahead and feel free to reach out to us and we can kind of guide you through that process. All right, next slide. All right, so most importantly, don't forget to mommy shake. So winter sanitation is very key in helping control your orchards of navel orangeworm. So make sure you mommy shake by March 1st and destroy the nuts on the ground. And additional resources can be found at our website at almonds.com/grower resources. So if you go, this is a link that you could click on and it'll take you to it, but it's under crop protection tools. There's a lot of resources. I know there's some one-pagers, and we had an irrigation summit a year or so ago, and we were able to pull a lot of great presentations and information on those. So all that is located right there at that link at crop protection tools from the grower resources tab on the Almond Board's website. So like I said, if you have any questions about this, feel free to reach out to us at fieldoutreach@almondboard.com, and we'll be able to help assist you through the process. So back to you, Drew.
Thank you, Ashley. And could you speak to what benefit the growers might get for enrolling or kind of going through the CASP program?
Yes, I can. So the benefit of this is being able for the grower to tell their story in terms to processors, consumers, purchasers of almond products. Most importantly, it allows you to tell your story specifically to what you're doing in your orchard. And it's great to see, because most of the time some people will take the assessment and be like, man, I really didn't know that some of these practices were happening in the orchard. And it's best because no one orchard is the same, and your neighbor may be doing something else. So we really, really encourage growers to be able to then say, hey, let's tell your story and our story as a whole industry to make sure we keep our markets open and our consumers well aware of what we're doing and how we're being so sustainable in the orchards.
Great. Thank you, Ashley. So I'm going to go through these next few slides really, really fast for the sake of time. I know we're running out here and we do want to get to your questions. So this is a new resource that the Almond Board worked on in partnership with USDA-NR. So this is free. This is a free resource, and there's a hard copy. Nothing's digital just yet. And I strongly advise you guys to email our field outreach team. You can see the email address here at the bottom. So this is going to cover almond orchard pests. You can see the variety there. Irrigation issues, where you could go ahead and get some calculations, some soil mapping and everything else like that. And also some quick tips for spray drift management. So again, free tool, and I'm going to give you a quick overview of what it is for navel orangeworm, just as an example, since we're on the topic. So navel orangeworm, you can see here, we're going to go over the pest, identification tools from the actual larva to the moth to the eggs, damage. Then we go into monitoring tips, and like Emily covered, there's quite a bit out there. So this gives you a bit more information in terms of what you're looking for when you're monitoring. And again, like Emily covered, you covered a lot of information there, a lot of good information. So here are some natural enemies for navel orangeworm. So how can you identify what you're looking for in terms of parasitism, in terms of the actual natural enemy or beneficial? And again, here's that email address. Please email our field outreach team for this free tool. We will mail it out to you. And with that, let's open this up for questions. So anyone can chime in through the chat or go ahead and unmute yourself and ask the questions. If no one goes first, I'll go through the questions that were dropped in the chat.
Okay, great. So Emily, we have a question for you from Kent Stenderup. How long is the female viable for breeding, hours and days?
So the adults can live, I think, perhaps a week or more. She's most viable really the first, second, third nights after a closing. I talked with Chuck Burks quite a bit about this, but really after that third night, she really doesn't have much fertility left in her. So it's really a short window where she's going to be producing and laying the bulk of her eggs, and it's within the first couple of nights.
Great, thank you. Drew, do you mind going to the next slide for credit since we are getting close to time?
Sure.
So here are the QR codes for CCA credit, and the other one is for the DPR quiz. And I'm also going to drop the quiz link into the chat in case the QR code doesn't work for you. But Emily, next question from Thomas. Does this negatively affect other insects, such as bee mating behavior?
No, the pheromone molecule that's in the mating disruptants has no effect on any other species. Occasionally, there may be other moths that are very closely related that have kind of a similar pheromone molecule, but that's really rare. And there's no consideration about the bees. Certainly, if anytime you're spraying anything, you want to do all of your bee safety practices, because we know that even just water droplets can have an impact. And so if you're doing a sprayable pheromone application, you want to follow all of the bee safety guidelines for any spray, but it's not because the molecule or the pheromone or the microcap has any level of toxicity. It's more that we know that even water droplets can impact bee flight behavior.
All right, great, thank you. So next question from Jesus. How far the male can fly looking for the female?
Yeah, that's always a great question, because the academics do what we call flight mill studies, and they'll basically tether a poor little moth on this thing and it'll fly around until it dies. And basically based on that, we know that there's a flight capacity of like miles, 3, 4, 5 miles. But the reality of how far they actually move in the environment, we really don't necessarily know that. In terms of how far an NOW is going to fly, I think has to do with until it hits its target. So with a female, if she's got resources for oviposition, she's going to fly far enough to get to the resources. For a male, he's going to fly far enough to find the female. I mentioned, though, that if he's not really actively searching for a female unless she's actively calling, and her active calling pheromone is very, very transient. And so he's not going to fly really, really long distances to a calling female just because of the time factor of how short-lived her pheromone plume is in the environment.
All right, great, thank you. And so Alec has a situation that he would like to discuss. It goes, our block of almonds is 18 acres, 6 leaf this year. There's a pasture and farmland surrounding us with a pistachio orchard 1 block over to the east, about 1,000 feet away, and an organic walnut orchard about 1,000 feet to the north. Is mating disruption appropriate or effective in our situation? We practice winter sanitation and have so far have had a low damage rate.
That's great news that the damage is low, especially given, proximity to pistachio that can sometimes be a source for almonds. Pistachios are much harder to sanitize and typically have bigger populations. Do you guys mind if I share my screen again?
Go for it.
Okay.
And while Emily's getting her screen up, those QR codes for CCA credit, you will need to make sure you have a online login through the Crop Advisor website, and then you can use their smartphone application. And then for just the DPR credit, you just open your camera on their smartphone, hover over it, you'll see 4 brackets around the QR code, and then you click the website at the top. But we'll answer more questions about those.
So is my slide showing to the group?
It is.
Yeah.
Okay. So this is a very common kind of a frequently asked question is, do I need at least 40 acres or 100 acres, or do I need a big block for mating disruption to, quote, work? And the answer is that it works the same. That mechanism of action of disruption works the same no matter the block size. But what you really need to think of, and these are great questions, and I like that the questioner actually gave me the landscape scale information. Think about the landscape scale and external pressures. Think about also the block shape can be very important. It's really about a perimeter to protected interior ratio. Certainly 18 acres is small. Most people would say it's not a viable mating disruption situation, but it really depends. The sprayable formulation being all of those tiny little point sources, that's a little better option for a small block than perhaps an aerosol is. That's kind of the conventional wisdom. For a pest that's quite mobile, like NOW, certainly bigger is better, but it doesn't mean that mating disruption won't have any impact. And so it really depends on the goals. And I forget the name of the particular questioner of, you know, they've got some pretty low damage. Are they looking to add some, you know, some disruption to smooth out, you know, maybe some impacts of their spray program, their insecticide program, and start thinking about pulling back, you know, that program over time. But I have a couple of pictures here where I show this kind of perimeter to protected interior ratio. If you look at, you know, so say each of these blocks is 40 acres. And so one of these has a 1 mile perimeter, for example.
We didn't see the slide, Emily. Sorry. Oh, there it goes.
Did it switch now?
Yep, it did.
Okay. But if you basically quadruple the acreage, you're only doubling your perimeter. And so this is why we often think, so now you have, you know, more of that protected interior to perimeter ratio when you have these big blocks, but it's all landscape scale, right? So if we don't have this in the Central Valley much, obviously, because we have all those contiguous acreage, but say you're on an island here and you've got nothing but pasture all the way around you. Certainly if these were very small acre blocks, then you would have very successful mating disruption. So it's a matter of sort of tempering your expectations. This is one that I like to show, and hopefully let me know, did it switch slides, Drew?
Yep,
Okay.
it did. Thank you.
So say these are 20 acres, right? And you've got this long skinny block and you've got pressure coming, you know, let's just say this is from the west and from the east. You don't have a whole lot of interior, you know, here where the female can fly quite a ways in and quite a ways in because you're long and skinny. In this particular 20 acre area, say her capacity to fly in is going to be this first box or whatever that example is because she finds resource there, then you do have, you know, a good amount of protected interior. Again, I think we often think of the point sources, more point sources like the micro caps or maybe even the mesos being a better option for smaller blocks.
All right, great. Thank you, Emily. So our next question was to Karen, but she did answer it within the chat. So I'm not sure if you want to elaborate a little more, but Neil asked, how much money will NRCS give for the NOW program? And you responded, the payment vary each year. At this time, it is in the neighborhood of $300 per acre. Is there anything you want to elaborate on that, or we go on to the next question?
If there's further questions on it, I certainly can, but I think that covers it. I think the payment right now is around $280, but it sort of depends a little bit on some other factors, and it might be a little higher than that. So in the neighborhood of $300 a year at this time.
All right, great. And then Alec asks, is NRCS in the process of hiring new personnel?
Yeah, we were somewhat restricted in what we could hire over the last several years, but we have been hiring staff, and I'm sorry that that's been anybody's experience. I've heard that on occasion, and I will just say some offices are extremely busy and they operate on a first come, first served basis. That's why I always encourage people, go in and get yourself started with it now. Even if you don't get all the way through the pipeline right away, it's the federal government. Folks, you're all working and living here. You know things move at a certain speed. So I just get yourself in, make yourself known, get the process started. And if you run into a roadblock, as I said, I welcome your calls and I will see what I can do to facilitate getting you some support. I'm happy to do that for anyone anywhere in the state.
Perfect. Thank you, Karen. And then Frank Trina asks, how many units are deployed when using passive dispensers? Guessing that's directed to you, Emily.
Can you repeat that question?
Of course. How many units are deployed when using passive dispensers?
The Trace mesos, the label rate is 15 to 28 per acre. If you read the label, I think they suggest the higher rate with higher populations. And those typically there's a kind of a spacing pattern that they go out in order to get like a good solid coverage grid.
Great. Thank you. Very good question, Frank. Okay,
So
any
that's
other questions?
Thank you, Jerome.
No problem.
And is everyone experiencing any issues with these QR codes and accessing the quiz? All right, Philip, I will redrop the quiz link in the chat. If that does not work for you, then I can send you an email as well. Oh, wait, that's what you wanted. Sorry, my bad.
Perfect. Well, if there are no more questions, I think that's it for today. I really appreciate Emily, Karen, Ashley, everyone that participated in this. I think this was a lot of good information to get out there. I know we all get inundated with navel orangeworm information and different components of management and what's what, but really I think this was a distilled version, really informative, and gives us a good idea of how to manage this pest, at least to the point of being able to control it where we can get us to a 1% or around there for growers to really achieve that return on investment with an IPM program. Again, an entire program is necessary. We'll stay on the line for a bit. If you guys have questions about the Q&A for DPR credits, or if you have issues with the scanning for the code, the QR code, we'll stay on. But that's it for today, and I'd like to thank all the attendees as well.
Yes,
Okay.
thank you, everyone. Thank you, Emily
you.
and Karen, Ashley and Jerome.
Yep.
Please
Thank you,
speak up.
Karen. Thank you, Emily.
Thanks, everyone.